Welcome to BSC 197 Laboratory. The laboratory portion of this course will be performed online this semester due to the COVID-19 pandemic. Any materials needed for this lab will be available on ReggieNet, including all announcements that will be made throughout the semester. You should check your email and ReggieNet often. This course will be offered asynchronously, meaning that all materials for each lab will be available at the beginning of the semester for you to go through at your own pace each week. Just because uh, all materials are available does not mean you can submit assignments whenever you'd like. All assignments will have strict deadlines, so please make sure you are paying attention to assignment due dates. All assignments will be turned in via ReggieNet. Each lab section will have an allotted time that is shown in your class schedule. During this time, you can meet with your TA on Zoom to ask any questions you may have concerning each lab. A tutorial video that will cover how to use ReggieNet and Zoom is available in this week 1 lesson. If you have any questions or technical issues in the course, you should contact the lab coordinator as soon as possible. The email is provided here. The sooner you email, the sooner your issues will be resolved. In all emails to the lab coordinator, you must include BSC 197 in the subject line so that the email does not get lost. Additionally, these emails must be sent from your ILSTU email account, as emails from Gmail or Yahoo often get marked as spam. The lab is broken down into 10 experiments and 2 lab quizzes. For each experiment, you will complete a lab report or a worksheet assignment worth 10 points each. You will also have 2 lab quizzes worth 25 points each for a total of 150 points available during the lab. Even though we are online for this semester, lab safety is an important point to go over because it will be applicable to all labs you will encounter throughout your educational and professional careers. As a general rule, food and drink are never permitted in teaching and research labs. No shorts or open-toed shoes are allowed to prevent injury due to spills or broken glass. You should always be familiar where all safety equipment is located in a lab, including fire extinguishers, chemical showers, and eye wash stations. You do not need to purchase a lab manual for this lab, as they will be provided to you as PDF documents through ReggieNet. You should always read and be familiar with the lab manual prior to watching any online lectures or lab demonstration videos, so that you have a good conceptual base of what the lab will cover. You'll understand and retain the information provided in the PowerPoint lecture more easily if you are already familiar with the concepts covered. Details of how to access the materials through ReggieNet is provided through the ReggieNet tutorial video located in this lesson. As mentioned previously, all assignments will be turned in through ReggieNet. Email submissions will not be accepted, and all assignments should be turned in as a PDF document. The process of how to submit an assignment on ReggieNet is also detailed in the ReggieNet tutorial video. The general format of a lab report for this course is outlined here. A detailed video that will cover the requirements of each section of a lab report will be found in the Introduction Lesson tab on ReggieNet. This will go over paper format by going over an example lab report. In the lab report introduction, you will provide the reader with information from external sources that are relevant to the experiment performed. In your materials and methods, your materials should be written. This is where you will record the procedures used in an experiment. There should be enough detail here so that you can replicate the experiment. In your results section, this is where you will visually represent the data collected in an experiment as a tables and graph. You will also have a results paragraph that describes the data in the tables and graphs in detail. Your discussion section will be an analysis of your results. You will reflect upon your hypothesis made in the introduction and state whether you support or reject this hypothesis. Finally, your conclusion is a short summary of the key take-home points from the lab. Again, a more detailed video tutorial that will cover the requirements of these sections in a lab report can be found in this introduction lesson tab. The introduction will have lots of background materials that the reader will use to understand the experiment performed. These external sources must be cited to avoid plagiarism. Citing a source that does not allow you to copy and paste full paragraphs and just put them in quotes, however. You must put the information in your own words. Good sources to use to find background information for your lab could be on PubMed, Google Scholar, or the lab manual. A primary literature source is not an online website. For example, billybobsonlinescience.com is not an appropriate example of a primary source. A primary source should be a journal article that looks something like this. Here is an example of a paper going over the role of catalase and oxidative stress found on PubMed. Your sources should be cited in MLA format and cited in text. An example here from the previous paper, we have the author. There are multiple authors, so we say et al. The title of the paper, the journal, volume number, date accessed, and the DOI. An in-text example would be if I took some information from this paper and stated cellular metabolism can often result in the production of reactive oxidative species. This is information that was found in this paper. I put it in my own words, and then in parentheses, I state where this information came from. This will be gone over in more detail in the paper format tutorial. If you do choose to plagiarize, the consequences are quite severe, including up to expulsion from the university. To avoid plagiarism, just cite your external sources and make sure you put that information in your own words. Do your own work, make your own graphs, write your own papers, and the semester will go by smoothly. This concludes the introduction material for BSC 197. Next, we will discuss different types of graphs and when to use them. The first graph type is the pie graph or pie chart. This is an appropriate graph to use when you describe parts or percentages of a whole population. For example, here we are looking at a total hamster population and splitting them into percentages of different colors. The next graph type is a column graph. This is useful to compare the same variable across different categories. You can have words in your x-axis, and the x-axis does not need to be evenly numbered or scaled. In this example, we are looking at hamster weight as our same variable across different hamster color categories. The next category is a line graph, and this is useful when you look at a change over time. Your x-axis does not need to be drawn to scale, and your x-axis can be labeled with letters. In this example, we are looking at hamster age versus hamster weight. on day 50, 60, and 70. And we can see as over time, the weight of these hamsters is increasing. The final graph that we will go over is called the scatter plot. In this graph, the x-axis and y-axis must be drawn to scale. The data will be plotted in its exact position and not at a labeled point, like a line graph. You cannot use this if you need letters in your x-axis. In that case, you would have to use a line graph. This is the type of graph used when constructing a standard curve, which you will do many times this semester. Typical graph requirements are that the x and y axes must be clearly labeled, including units of measurement. The title should be clear and descriptive, but not overly long, and the data used to assemble the graph must be shown with appropriate calculations. On a graph, this is typically represented with error bars calculated from the standard error, which we will go over in just a little bit. For example, here on this bar graph, we show these error bars. And this shows the reader how accurate or how reliable these measurements are. All right, so next we will go over some statistical calculations that you will need to know to perform statistical analyses throughout the semester, including mean, standard deviation, standard error, and t-tests. To calculate the mean, you simply sum the total number of replicates, or the individual points, and divide it by the total number of replicates. For example, if we measure 6 individual sunflower plants in centimeters, to get the average of these 6, you would add them up and divide by the number of replicates, which are 6. The average height of these sunflower plants is 89.17. The next stat equation will be standard deviation. Standard deviation measures the variability of an average, or the mean. In this equation, n is the number of replicates in a data set. X squared within parentheses is the sum of squares of x. And x squared outside of the parentheses is the square of the sum of the values of x. This will be explained in a later slide. As mentioned, standard deviation measures the variability of the mean. For example, if we have 2 data sets here, the mean for both data set A and B is exactly 33. But if we look at these 10 individual points, the variability of each individual point is much more variable than data B, which is more consistent. When we calculate standard deviation from this set, we get a large number, indicating that the data in this data set that's represented by the mean of 33 is highly variable. In data set B, the standard deviation is quite low, indicating that the majority of data points are consistent around the mean of 33. As mentioned before, x squared within the parentheses does not equal x outside of parentheses. As mentioned before, x squared is the sum of the squares of x. What that means is for this data set, we would take the square of each of these values and add them together. So in this situation, x squared would equal 47,949. When the exponent is outside of the parentheses, this indicates this is the square of the sum of values of x. What that means is to calculate this value, you will add up each individual data point in the set and take the square of that value. So the value of x squared outside the parentheses is 286,225. It is important to remember the order of operations and not to switch up the position of x squared within parentheses and x outside the parentheses. To make sure that I don't switch up these two values, I like to refer to the fast food chain In-N-Out Burger. So you think that the exponent inside comes before the exponent outside. Remember that you will want to solve for your parentheses first, then exponents, then multiplication, division, and then addition and subtraction when performing standard deviation calculations. An example here is our standard deviation of these two values. If our x values are here, we can calculate x and x squared and plug them into this equation. N in this situation is 5 because we have 5 individual data points. The next statistical calculation will be standard error, and this estimates the reliability of the mean. And this is directly related to standard deviation. To calculate standard error, you will take the standard deviation divided by the square root of n, where n is the number of replicates in a data set. So from the previous example, to calculate standard error, we'll take the standard deviation calculated from this set, divided by the square root of 5 to get a standard error of 0.006, rounded off. It is important to not round too early when calculated standard error. If you round your standard deviation value, you may get a drastically different value for standard error. And this will be discussed later. Going back to that example previously where we have the same average of 33, a high standard deviation also will result in a large standard error. A small standard deviation will result in a small standard error. In the situation in these two data sets, data set B would be highly preferred. As mentioned previously, you do not want to round your values until the end. With this data set, without rounding until the end, the standard deviation of this data set is 0.012461942. But when we're calculating standard deviation, if we were to round every value calculated, including x squared in the parentheses, x squared out of the parentheses, to the first 2 decimal points, the standard deviation of this data set would be 0.02236. These values are drastically different. They're statistically different. And this would not be a correct answer. So it's very important to not round values until the very end. Excel is your friend when you are performing these because all stats can be calculated using Excel. It is important, however, to be able to perform these stats by hand. There will be an Excel tutorial video on how to perform these stats in Excel in this lesson. The next statistical analysis that you will perform is a t-test. A t-test is used to determine if the differences between 2 sets of data can be explained by random chance. Essentially, if you have a control and an experiment data set, are the differences in the results due to a real trend, or are they just due to random coincidence? To calculate your t-value, we will use this equation, where the mean of E is the average of the experimental data set. The mean C is the average of the control data set. SE of E is the standard error calculated from the experimental data set. And SEC is the standard error calculated from the control data set. You will calculate a t-value, which will be compared to a critical t-value chart to determine statistical significance. In order to find the comparative critical t-value, you first need to calculate the degrees of freedom, which is calculated by n of E plus n of C, this sum minus 2, where n of E is the number of experimental samples in the data set, and n of C is the number of control samples in the control data set. For example, using the stats we previously mentioned, we calculated the average and standard error of a data set. In the control data set, there were 5 samples. In the experimental data set, there were 5 samples. We will plug in the average of the experimental and the average of the control in for these values, 0.230, 0.194, divided by the standard error squared of each data set. Plugging this in, we get a t-value of 1.83. Using the degrees of freedom calculation, each data set has 5 samples, so it is 5 plus 5 minus 2, which comes out to be 8. We can then reference this chart, where we can compare that calculated t-value to this chart to determine our p-value. Our p-value is the probability that the differences in 2 data sets are due to random chance. So you can think of the p-value as a percentage. A p-value of 0.05 or less is considered statistically different, meaning the differences in these 2 data sets are not due to random chance, but due to the experimental procedures applied. A p-value of 0.05 could be considered a 5% chance or less that the differences are due to random chance. So a very low p-value is desired. In this chart, the degrees of freedom are on this axis, in this column. On this axis are the p-values. And all of these numbers are the critical t-values. So in this example, our degrees of freedom are 8. So we find 8 on the degrees of freedom. Our t-value is 1.83. And we will find where this number lies between all of these critical t-values. For example, 1.83 is smaller than 1.397. 1.83 is not larger than 1.86. So our t-value lies at this position. We can then go to the top of our column where our p-values lie and say our p-value is greater than 0.1, but less than 0.2. In this situation, you report this as p is less than 0.2. P is not less than 0.05, so the difference is not statistically significant. If our t-value, let's say, was 2.9, we'd find 2.9 is larger than 1.8, 2.9 is larger than 2.3, 2.9 is larger than 2.8, it is not larger than 3.35. Our t-value would then lie here if our t-value was 2.9. We would then say our p-value is greater than 0.01, but less than 0.02. In this situation, the p-value would be less than 0.05 and would be considered significant. This concludes the introduction material for BSC 197. If you have any questions regarding any of the information, please contact your TA via email.